So today we're really kind of focusing in on factoring and solving with factoring and what factoring looks like for polynomials and just regular monomials. And so if I look at the warm-up, I just getting y'all to practice solving. So 2x squared minus 4 is equal to 8. What would I do to solve this? Move the 4 over. 2x squared is equal to 12. What else do I need to move over? X squared is equal to 6. What else do I need to move over? Okay. So anytime it's an even power for your root, it's going to have that plus or minus sign in front. And so x is equal to a positive and negative square root of 6. What would I need to move first on this next one? So it leaves me with x minus 1 cubed is equal to 5. What would I need to move over next? Is there anything outside? We gotta get rid of this. So the cube root. Is 3 an odd number or an even number? Odd. So that means it doesn't have the plus or minus. So x minus 1 is equal to the cube root of 5. What do I need to move over next? The 1. So x is equal to 1 plus the cube root of 5. Number 3, we have 3 times x minus 6 to the 4th power plus 11 equals 15. What do I need to move first? The 11. What would I need to move next? It's gonna be kind of like the number. Say it's gonna be kind of like number 1 there. We have to get that term isolated. What would I do next? So take the 4th root. Is that an odd or an even root I'm taking? So it's going to have a plus or minus. So x minus 6 is equal to plus or minus the 4th root of 4/3. If you actually need to find that number in the calculator, there is a 4th root, and you just have to take the control and the caret that we use to get to the exponent, and it'll give you a fraction where you can work with. What's the next thing that we're going to do? The reason we're not going any further is those roots are not things that we can actually find a real number. There's not a number times 5 3 times that's going to give you number times itself 3 times that gives you 5. There's not a number times itself 4 times that gives you 4/3. So we're just leaving it there. And you have 6 plus or minus the 4th root of 4/3. And then on the 4th one, we have x cubed minus 27 is equal to 0. What would I do first? So x cubed is equal to 27. What would I do next? Take the cube root. Is that an odd or an even root? And so there's not a plus or minus. There is a number times itself 3 times that gives you 27. That's 3. So that's the answers. Factor tree. We're thinking about what factors. What would multiply together to give me 24. So factors, remember, are things that can multiply together to create the number. What factor pairs? That means 2 numbers that can multiply to give me 24. Someone give me 2 numbers that can multiply to give me 24. 12 and 2. What's another set? 8 and 3. 6 and 4. 24 and 1. Is there any other ones? No. I mean, you could have reversed them, but that's kind of, we've understood. We're at the point where we should be able to understand that that's the same thing as this. How did you know if those 2 numbers are a factor pair? Because they multiply to equal 24. 2 times 12 equals 24. 2 times 13 doesn't equal 24. That's how we know. Can 5 times something equal 24?
No.
How do you know that? So if I take and divide 24 by 5, I end up with a remainder. It won't divide evenly. Oops. So we're talking about different factors. And if we were to try to find out what the prime factorization is, we often used what was called a factor tree, right? And you kept going and you kept going, okay, I need to get smaller and smaller, right? Well, Sharice and Gemma both want to begin their factor tree for 24. Sharice said 2 and 12, and Gemma said 3 and 8 were her first starting point. Sharice said it doesn't really matter. We're all going to end up with the same prime factorization. But Gemma says that they're going to get it to a different factor pair. Get it different because they start with a different factor pair. Who's correct? Why don't y'all complete both of these and see what that is? So did they come up with the same thing? There's only one prime factorization that's going to work. Doesn't matter how you start it. I actually do a different method. The method I use is I have to do what I call it upside down division. I start with a number and think of the first prime number I can think of that divides in. 2 gives me 12. What's a prime number that can divide into 12? 2 gives me 6. Prime number. 2 gives me 3. And so that's my way of doing it. I don't really care what method you use to find your factorization. Just find it. So when we consider the expression 2 times 2 times 2 times 3, how do we know those factors? How does that relate to the factors determined by Sharice and Gemma? Well, Sharice was hers 2 times 12? Yeah. So here's the 12 and here's the 2. Gemma had 3 times 8. So here's the 8. How do these relate to 12? If you multiply them, what do they create? How do you know if a number, like if I give you 7, how do you know if it's a factor of 24? It's besides having it memorized. Let's say I give you a weird one like 53 and you had to find the factorization. How would you know if 7 was a factor? You divide. And if it has a remainder of 0, then it's a factor, right?
What?
Means if it divides evenly and doesn't have anything left over.
Yeah.
And so what is a factor when you divide? What is a remainder, excuse me, when you divide? 0. Come up with a factor tree or the upside down division. Sorry, went too fast. So I want you to create the factor trees for 66 and 210. Okay, and so when we have the factorization, you should have come up with 2 times 3 times 11 is equal to 66. 2 times 3 times 5 times 7 is equal to 210. Does it matter if we went the same way to get to the factor tree? No, because the end of your roots are all going to be prime. And so some of you may have had the shorter route. Some of y'all may have gone a different route. But you will end up with the same set of factors if you get down to the prime numbers. Let's look at Ping and Sheila, or Shalisha. Shalisha, maybe? So they're trying to find out the greatest common factor. Who found the greatest common factor, Ping or Shalisha? So Ping says it's 3x, Shalisha says it's just 3. Do you include the x in your greatest common factor?
No.
Yes. So you include the variable.
So Ping would be correct?
So Ping is correct.
That is looks so weird. Looks like,
Because Ping says that it's 3x is what could factor out. And so remember we started off with 3x cubed plus 12x squared minus 36x. So the 3, everybody kind of understood. These all came out and had a 3 in them. Do all 3 have a variable? So that means that what is the smallest variable of those 3? Well, just an x. So that's where the 3x came from. So what is 3x cubed divided by 3x? Well, 3 divided by 3 is 1. X cubed divided by x is x squared. 12 divided by 3 is 4. X squared divided by x is x. Negative 36 divided by 3 is negative 12. X divided by x is 1. So that's how Ping came up with that factorization.
is that, did you, correct?
Is that an x cubed right there? The first one?
Yes. Right here,
Yeah.
that's squared.
You get tissue.
Somewhere, if there's any left, it's over there by the phones. Excuse me. So who would we want to factor completely from? Ping or Shalisha?
Ping.
Ping, because she has the most, or he has the most out. And so let's look at Ping's. We have 3x, x squared plus 4x minus 12. We need to factor out this trinomial. It's an Asian name. And so when we factor out that trinomial, that's where we use the box and the x. Remember, the first goes in the top right hand or top left hand. The last goes in the bottom right. And this comes down here to the bottom of your x. What went up here to the top? The product of these two. So what two numbers can multiply to give us this, but add to give you 4x? So we need them different signs, right? One needs to be a positive and one needs to be a negative. They both will need to have x. 6 and negative 2. Because 6 minus 2 is 4. 6 times negative 2 is negative 12. Oops, not 4x. Does it matter which spot you put those two things? No. So now let's look at our factors. Out of this first column, what's something that can come out?
X.
Yep. They both have an x, so x and our lowest power is first. At negative 2 and a 1, there's not a shared coefficient. 6x and negative 12. What's the biggest number that can divide into 6 and 12? And it was positive, so we put a plus. First row, x squared and positive 6x. There's an x in both of them, and our lowest power is 1. Negative 2 and negative 12. And this, because the closest sign was negative, so that's where that negative came from. So our factors are these. It's not 3. How would I figure out where I cross the x-axis? How would I find my x-intercepts? Well, you say each of these equal to 0. And you solve. So x equals 0. And no one cross at 0. X equals 2. And no one cross at 2. X equals negative 6. So now I'm going to cross there. So the highest power was 3. So that means that it's a cubic, which means I'm either one of these two. How do I know which design I am? How do I know if I'm left or right? You're A. So we had a positive A. So that means the right-hand side needs to be positive. So that means that our first side is going to be going down. In between the first two is going to be above, below, then it's going to go below, then it's going to go above. We know each time we touch and go all the way through because there's nothing with a power on it when we get it factored. I want y'all to factor out, we're going to do the same thing for A, B, C, and D. I want y'all to look at those. Which of those do you want me to work through with you first? Do you want me to do B
Yeah, B.
or C? B? So we're going to look at 2x squared plus 6x. What is our greatest common factor? Well, what number divides in both 2 and 6? What number divides into both 2 and 6?
Oh, no, just
2.
2.
Is there an x in both?
Yes.
And so 2x squared divided by 2x, x. 6x divided by 2x. Do I have a power left? So we have the highest power is 2. So that means that I'm either going to go up or down. This will be if my A is what?
Positive or negative?
Positive. A is negative. So which one is it going to be?
Oh,
They both go up and it goes down between. So you do that for the other 3.